Welcome! Let's take a look at applying the fundamental theorem of calculus to definite integrals. And what we want to do is evaluate the following integrals. The fundamental theorem of calculus says, suppose f of x is continuous on the closed interval from a to b. Then the integral from f of x dx is equal to capital F at b minus capital F at a, where capital F of x is any antiderivative of our integrand, small f of x. That is, if I take the derivative of capital F of x, then I end up with my integrand, small f of x. So our first example here is the integral from 0 to pi over 2 of sine of x dx. Our integrand is the sine function, which is continuous over all real numbers. So certainly continuous over the interval from 0 to pi over 2. So let's go ahead and evaluate this integral. Now, the antiderivative of sine of x is negative cosine of x. So we're going to write a little more than maybe I typically would. We're going to say that that antiderivative is negative cosine of x. And as is hinted here in the fundamental theorem, I can always check my work by taking the derivative of my antiderivative and see if I end up with the integrand. If I were to take the derivative of my antiderivative here, I would have f prime of x is equal to negative, and now the derivative of cosine of x is negative sine of x, which does in fact end up giving us positive sine of x. So my derivative of my antiderivative matches the integrand I started with. So now to finish evaluating this, I need to evaluate capital F at my upper limit of integration and then subtract antiderivative at my lower limit of integration. So this is often written this way. We would often write this is negative cosine of x evaluated at x equals pi over 2 as my upper limit and x equals 0 as my lower limit. And then we simply evaluate the antiderivative at these points and subtract the value of the upper limit minus the value of the lower limit. So in this case, we would have negative cosine of pi over 2, that's my upper limit. That's my upper limit substituted into my antiderivative, minus negative cosine of 0, that's my lower limit substituted into my antiderivative. And now cosine of pi over 2 is 0, so that first term is 0 minus negative, and then cosine of 0 is 1. So I have 0 minus negative 1. So the value of this definite integral is 1. So looking at our second example, we have the integral from 1 to 5 of 1 over x dx. So we want to first find the antiderivative of 1 over x. Now it might be tempting to think that if we think about 1 over x as being x to the negative 1 power, that my antiderivative, to find that function, I would in essence reverse engineer the power rule. But if I try to do that, so if I got x to the negative 1 from taking a derivative, that means I subtracted 1 from the exponent. So therefore, I must add 1 to the exponent. So my exponent would look like negative 1 plus 1. And my exponent would become 0. I would have x to the 0 power. A couple of issues. So first of all, if we would have x to the 0 power provided x is not 0, which means that my antiderivative would be 1 provided that x is not 0, and the derivative of 1 is 0, not 1 over x. An additional issue is if I were to try this, and where we add 1 to the exponent to undo the power rule, we also have to divide by that new exponent. And in this case, I would have division by 0. So that's another issue with why we can't approach this antiderivative from a power rule perspective. So what we do need to do is we need to recall that the derivative of the natural log of x is 1 over x. So my antiderivative should be the natural log of the absolute value of x. With this as our antiderivative, we can verify that the derivative would be, in fact, 1 over x. So having found our antiderivative, we can say that this is the natural log of x, absolute value of x, evaluated from x equals 1 up to x equals 5. And then evaluating this, we start with our upper limit. So we will have the natural log of the absolute value of 5 minus the natural log of the absolute value of 1. Now we know that the natural log of the absolute value of 1 is 0. So the value of this definite integral is the natural log of 5. I hope you find this helpful.